Alright, so this is part 1 of the CST tutorial, which is going to cover the basics, opening up CST, building a very simple model, and this is all modeling metamaterial type structures, and it's going to cover setting up the simulation parameters, running the simulation, and finally looking at the results and interpreting them and how to export them out. Alright, so to start off, click Start. It says Windows, go to Programs, and then find wherever you've installed CST Design Environment. Click it. Typically it takes a lot longer than that to load up, but sometimes it loads fast, sometimes it loads slow. So when you first open it, you'll get this little Welcome to CST Design Environment. It's like a wizard type thing where basically you can open up past projects or start a brand new one. Now in our case we want to start a brand new project, so for our purposes in metamaterials we want to deal with CST Microwave Studio, which is basically high frequency. EM Studio is low frequency electrostatics basically, and other low frequency applications. Particle Studio deals with actual individual electrons, protons, that kind of stuff. Design Studio is a cool little tool that's sort of like PSpice on steroids. And then PCB Studio I'm not too familiar with, and I'm not too familiar with Cable Studio either. But we're gonna start from scratch. So go ahead and click CST Microwave Studio, double click it, or just click OK. Alright, so after you click that, it's going to ask you if you want to start some kind of template. And in our case, yes, we definitely want a template, because in the case of modeling metamaterials using computer simulation software, CST, acronym for it, we want to use the FSS unit cell template. So go ahead and select it and click OK. 1 minute, pause, I just need to check something. Make sure this thing is recording. Okay, alright. Click FSS unit cell. Alright. So the first step. Step 1 is to model the structure. It's going to be something very basic. In my research, when I first started it out, we were dealing, just to get it running and to see and to double check our results with other people, we just wanted to make sure that we could model a simple inductive screen and capacitive screen. So I'm just going to model a very simple round hole capacitive screen. Now you don't have a schematic for this, so you're just going to be going on what I tell you. But it's very simple. So start off by making a brick. So go up here to create brick, click it, and it's going to ask you to enter the first point in the working plane. Now there's a bunch of ways you can do this. You can either directly double click, there's a couple other ways, but the way I do it, because I like to be precise, is you press the tab key on your keyboard and this little window over here will pop up, and it's going to give you it's going to ask you to specify a point in a Cartesian plane x and y, and basically to specify a brick, the actual square, the 2D part of the brick, you need to enter in 2 points that have both different x and y coordinates, and I'll demonstrate that. So let's make a brick 48 by 48 units in general. So to do that, and we want to also center it around the origin. So to do that, you'd simply do 48 divided by 2 and 48 divided by 2. That's going to give you a point typically around here, or maybe up here. It's going to be in the first quadrant, which is the important part. Now, however, even though this will give it to us, from now on, whenever you build your model, it's better not in all dimensions, or not in all entering points or building the actual physical structure, but in this case it's better to use variables. In other words, we want to use a letter to specify that 48, or the side of our square. In this case, G happens to be the periodicity. So click OK, and whenever you enter in a parameter that has not been defined, it will ask you to define it. So in our case we want it to be 48, and this is pretty much the length of the square, right? So click OK, And now you can see we get a point up here somewhere in the first quadrant. So now it asks us to specify a second point, right? Because a square can't be defined with only one point. You need at least 2 points to define a square. So now the second point. Now to get this guy centered around the origin, a very simple way would be to put an opposite symmetric point from the first one in the third quadrant. And you can do that by doing negative g divided by 2 and negative g divided by 2 for the x and y coordinates. And that pretty much goes down by g divided by 2 and then this way g divided by 2, and it will give you a point up here and a point up there. And if you click OK, you can see that it gives you a square. It gives you a square where with a variable height. Now we want to make the height constant, fixed, right? So to do that, same procedure as before. It asks you for the height of the brick to press tab on your keyboard and enter in a height of 5. But remember, you want to use variables, so put in t and then select OK. Call it 5 and call it thickness. Now you have your model. Now you have your solid modeled. It's just a square brick, right? So let's call it our screen, because that's really what it is. And in AutoCAD and other things, material isn't too important. However, in this case, material is very important because the type of material affects the way that an electromagnetic wave will propagate through it and how it will reflect and transmit. So start by loading from material library, click it, and we're looking for copper. It's in alphabetical order, very easy to find, so click copper, press load, and now you have all your parameters set. Press OK. So now you see we have a slab here centered around the origin. You can see that, and that forms the basis for our inductive screen. Now we need to cut out the next part, and this is the last part. We need to basically cut out a circle in the middle of the screen, and in that circle needs to be air, or vacuum in short. So to do that, go over here to create cylinder, click it, and it asks you to specify a center point in the working plane. So go ahead and press tab, and because we want that circle centered at the origin, put it at 0, 0 for the XY location of the point. Press OK. You can see where it's centered right here. Now it's going to ask for a radius. Call it R. Press OK. Let's make R equal to 15. Call it radius as a description. Okay, now it asks you to enter the height. Now because we want this sucker to cut out, because we want to cut out a circle out of this thing, we want the height to be the exact same height of our square brick here. So go ahead and just call it T again. And now you can see the circle is almost inside, perfectly inside of our square brick. Okay, so now it asks you for an inner radius. In our case, we don't want an inner radius. So to avoid this step, just press escape on your computer. Then this will come up. So because it's a cutaway, call it cutaway, just for convenience. However, everything else is fine. However, you need to change the material. You need to change it to vacuum because we want to basically put a hole, a cutout, a vacuum hole. In other words, air. That's essentially what it is. Now, when you press OK, because now we're finished, you're going to be introduced to an important concept of Boolean shapes or shape intersection. And basically what that is that any time in CST, or in your model space, and your model space is basically all this space right here, anytime two objects of different types of material intersect, you're going to get this shape intersection window coming up, and it's going to ask you what it should do. Now there's a bunch of different